This next talk is from our Breaking Ground track. Please stay tuned for Chen Cao and Daniel Stinson-Diess presenting their talk, A Serverless SIEM, Detecting All Baddies.
Welcome to our talk, everyone. This is us presenting on a serverless SIEM on a budget, how we detect all baddies at Cloudflare with our custom SIEM. We're glad everyone was able to find this room, and luckily they gave us the biggest room since we knew this talk was going to fill up. My name is Daniel. I'm a security engineer on the Cloudflare team, and Chen's going to give us a little intro about our team and ourselves.
Hi, my name is Chen, and I'm also a security engineer on the detection response team at Cloudflare. This is my fourth Hiker summer camp, and this is Daniel's third one. We both have been with Cloudflare for more than 2 years, and over the past 2 years, we spent half of our time building this project called a DApp, and spend the other half of time on instance response and building alerts using the project. So today we're going to talk about how we build this serverless SIEM that meets all of our requirements at Cloudflare and why we are building it. So first, let's talk about what is Cloudflare. Cloudflare is an internet company that offers lots of network performance and security solutions for internet sites and teams. As you can see here, there are 25 million internet properties using our services. Our network is in over 200 cities and more than 100 different countries. We block 70 billion cyber threats every day, and we have over 1,900 employees all over the world. That means we have a lot of logs. As you could probably imagine, we run tons of different services on our production servers, and we have many SaaS applications to support our daily businesses. And lots of these log sources scale with the number of data centers we have, number of requests we are serving in our network, and number of employees we have as a company. And we are growing very quick as well, which also means the log volume would grow very quick. So the question here is, where do we put all these logs? The traditional answer is a SIEM. It's more or less the core tool for any detection and response team right now. Especially at Cloudflare, we have a giant elk stack where we have already pushed tons of logs to it. So the obvious answer is to just use the elk stack. But hold up, an easy choice may not always be the best option for us. So personally, I had experience of managing a SIEM cluster, and that's probably the worst experience ever in my career. Patching vulnerabilities is never a fun thing for anyone. But as a security system, I don't want any security issues in it either. Besides that, after more and more logs pushed to the SIEM, we just keep seeing random 500 errors, and a lot of times we have to wait for minutes for a query to be executed. It's also very hard to scale. For example, if we're under some large-scale attack, we might receive tons of logs within a short period of time. And a traditional SIEM usually won't work well if the log volume changes a lot. Also, if we want to ingest logs from our global network, most SIEMs would require a logging agent to be installed on every single server. The performance of the agents are usually not very great, and at Cloudflare, we are also very careful when we have to install our third-party program on our servers. Luckily, our detection response team has a strong software engineering background with interests in security work, and we try to engineer our way through problems for the long-term fix rather than buying a short-term solution. So why don't we start over and think about what could be the best option for us, then build our own SIEM? In the design meeting, I look over at Daniel and tell him, let's do this live and we will build our own SIEM. Let's start from the beginning and see how a SIEM should work. High-level flow from left to right. We have some log sources for sure. That's like the most important thing for any SIEM. Then we need to have a way to ingest the logs to the system. After that, we need to have some ways to build detection rules to find if there are any suspicious activities in the log events. Then after that, we need to have a way to notify the team about the potential threats in the log events. And finally, we need to have an automation method to automatically resolve the instance or enrich the alert so that when real human working on the instance, it's easier to be resolved. So basically from left to right, there will be fewer and fewer events being filtered out until we have only real actionable potential instance at the end of the pipeline. We have, so from that high level overview, we come up with these requirements. And we have a lot of servers in our network. So the SIEM needs to be able to receive logs from our global network easily. Also, performance is very important for our servers. So the transferring process of these logs needs to be efficient. Also, as a security product, we definitely want the transferring process to be safe as well. To have a better experiment of using the SIEM, the search needs to be efficient and easy to use. No one wants to wait for minutes for the results of a search query. Rules can also be aided easily, and it needs to align with the industry standards so that we could migrate community rules easily to our SIEM. And of course, it must be affordable as well. The whole system shouldn't require dozens of engineers for management or millions of dollars for usage. To meet all the requirements, after evaluating and comparing different options in the industry, we decided to build our own SIEM using serverless architecture on GCP. Obviously, serverless doesn't mean like everything is running up in the air. It's just no servers for us. So that we don't need to patch the system. It will be auto-scaled, it's cheaper, and there is no operational cost on managing servers. Also, GCP has a lot of great services that are allowing us to build up this system very, very quickly. We use different log tiers from GCP. We use cloud logging as our hot storage, mainly used for quick searches. It has the benefit to use the sink to push everything to both GCS and BigQuery. We use BigQuery as our warm storage for searches during incidents for detections. GCS, we use it as backups and code storage in case of emergency. Our main source of computing logic is in Cloud Functions, and we chose Go as our primary programming language because Go is very good at handling concurrency. As you could probably imagine, in our SIEM, we probably need to pull logs from different telemetries and process them in parallel. And Go has a lot of benefits of doing that. And we want everything to be terraformed as well, so that it will have better deployment experience and easier access controls. Then finally, we could turn the previous high-level diagrams into a more detailed pipelines. This now looks more actionable for us to start working on. I will hand over to Daniel to talk about more details on how we implement this diagram step by step.
So at this point, Chen's kind of gone through the motivation of why we want to build our own SIEM at Cloudflare against existing solutions. So now let's walk over what the life of an event looks like throughout the SIEM, starting with probably the most important phase, log ingestion. Sometimes SIEMs require complicating parsing, logic, and complicated configurations, so we can try to figure out how we can ingest our data. As you can tell, there's lots of different log sources and that we need to parse and understand, and the single largest box on this page is log ingestion. That's because it's probably the most important job of this entire project. It needs to be the most reliable since we can't drop anything, and we need to be able to query this, and it needs to be the best source of truth. So there's lots of ways we can get data into this GCP SIEM, and there's lots of different data we need to get in, and not all methods are going to be good for all logs. There's a lot of logs for SaaS products where you're not going to just have a syslog endpoint for them, and there's lots of logs for EDR products and other things that need a lot of correlation and pre-processing. So let's figure out what's the best method for each. The first method, and probably the easiest one to think about from an operations point, is just to write logs to a GCS bucket. This is really easy for your operations team who might already be writing logs of your backups to some S3 bucket. Then instead, they can also copy the query logs and the audit logs for that same server to GCS as well. This is really easy because it's less installations, and once they write it there, we handle all the processing in batches, and it can handle large fluctuations really quickly. One example where we use this internally, which is probably our most successful and highest volume log source, is Cloudflare logging. Cloudflare supports a product for our customers, which we use, called Cloudflare logging, where you can export your logs in a stream directly to a GCS bucket. They'll update this file when there's new logs up until a certain size, and then start a new one. This makes it really easy, so every time a new incremental write is written, we get a GCS notification where it says, hey, there's new data. We grab that in a compressed form, write that to both cloud logging, and start running detection logic on it. This is super simple, and it's a lot more efficient than even the primitives that GCP gives you for GCS ingestion, since they have a service managed for you called Dataflow, which actually turns out to fail a lot of the time, and it's a lot more expensive and doesn't fall into our serverless principles. Another way we can get data into our SIEM is through BigQuery. A lot of services, especially within the Google ecosystem, support native exports into BigQuery from your Google Workplace logs if you're using that environment, as well as taking data from Google Analytics or just a spreadsheet for ad hoc analysis and putting that into BigQuery. This is really easy, and we tried this configuration at first, but the main problem we realized is it takes up to 3 days to get the logs for a login event from the event happening all the way to being ingested in BigQuery. And this is just horribly slow. If you think about it, having 3 days for an attacker to have unfettered access before you even know that there was a bad login is horrible, and that's not good for us. So how can we do this quicker? That's when we came up with our generic log pull method. We realized that almost every SaaS API and even internal applications that support audit logs are going to have their own interfaces. So let's create one that we can morph into using all of these and run them on a set schedule. As you can see in the architecture at the top right, every 5 minutes we're going to reach out to Google's APIs. We're going to fetch all of their logs and write them to the proper destination. In the bottom right, you can see the Go contract that all of our log pull methods must conform to this interface here, where they get all the audit logs, write them to their topic, and that's really all that the clients have to do. This is a really simple method, and conceptually, and over half of our logs use this. But the real con is you have to implement this for every unique log source. Over time, we've developed lots of libraries that help keep this implementation shorter and shorter each time as we reuse them, and it's turned out to be really useful. We have this running on 5-minute crons for something like G Suite, and other things that require more time to update the data runs on a 1-day schedule, or whatever you really need to make. It's pretty customizable. So once you get a life of an event through ingestion, the next topic is doing analysis on this for detections, or maybe it's incident response. We think of this in 3 main buckets. There's a stream analysis where you can look at one event, batch analysis, or ad hoc search. How we differentiate these is, do we need to look at more than one event for the detections? That differentiates between stream and batch. And then if batch, it's also batch if you need to look at events across the different telemetries. We definitely should support querying across those. Then of course, during an incident, you need to be able to query those logs easily, quickly, and ideally, if you've done a similar query in a past incident, you should have a really easy way to pull up that saved search and share them across the team. So let's look at how this works. Stream analysis, we use Google's common expression language, which it has a really nice Go library, and it's pretty easy to read the rules and understand them and write them as an analyst. On the bottom left, you can see here is an example cell rule, and this cell rule utilizes a bunch of different features. It checks if the log field is present in your alert, because sometimes the log isn't always there, and you want to try to run this on every log, even if those fields aren't there. So you can check that. You can do strings contains search to see if a substring is in there, and you can do a third-party lookup with a macro that you can write customizably and to check what the vendor is for this MAC address. We've written a lot of these custom macros that do things like IP address enrichment, look up someone's groups, and other things. And you can really just see this is a stream rule on the right, which is roughly how they look. And it's pretty easy to get the gist of if someone's exporting something, let's create an alert. The other way of doing analysis is batch analysis. Batch analysis is when we put all the data into a BigQuery and you write your detection logic as a SQL query. We run these as BigQuery scheduled queries at whatever interval and time frame someone defines in their query logic. On the bottom left, you can see what the time frame is configured as 15 minutes for this rule, where we're looking for failed Okta MFA. And then every 15 minutes, it's going to run that above SQL expression, and it'll check how there have been more than 4 failed MFA attempts in the past 30 minutes. Running that every 15 minutes will make sure we see that, and then the type any tells you that if there's any results at all, we want to create an alert. Other types we support are if there's a new added field. So that's useful if you're looking at all of the DNS resolvers on some Linux host, and if you add a new DNS resolver to their host file, then we should look at that because maybe they're deviating from our standard Cloudflare configuration. We wanted to make sure this was really easy to write for our developer, for a development point of view, for our detection engineering team, because this is not the common solutions that everyone's used to. So we have all of our detections written as code, managed with CI, and everyone has a local testing environment where they can check their rules and match the correct syntax, have data piped to them to do evaluation of if the logic is correct, And you can also, and once you check your code into CI, it'll test all of your rules, make sure there's not too many false positives or false negatives, and make sure that your queries run in a performant way. The rule format, if you've noticed, is largely a Sigma rule. We've made this a lot easier for our team to write by writing some VS Code plugins which do the validation and removes a lot of the boilerplate for creating a new rule. You can see here that we have a macro that you can write that'll generate the new rule. As you go onto certain fields where you have specific options, it shows you a drop down of what you need to write and creates the new UUID, the date, all of these things that just take up time that you don't want to do. We also recommend that everyone installs the Red Canary MITRE ATT&CK navigator while they're in VS Code, because then it shows them in their detection rule that which each of these MITRE ATT&CK tags will mean. So this is the life of an event from both ingestion and detection. Now Chen's going to show you what it looks like once we've filtered those to the events that we think are malicious.
Thanks, Daniel. So after detection engines found some suspicious activities in the log events, we need to send them over and notify the team about the potential threats. So currently, we have a cloud function called Sirens to handle notifications. It is a lighter version of Alerts Router, but meet all of our requirements. There are mainly three functionalities here. The first one is deduplication. For example, if we found someone had 5 failed MFA attempts within 30 minutes, then this same person made a 6th attempt, then a 7th attempt. We won't generate 3 different tickets. Instead, it will just be 1 ticket and all the other events will be comments added to the original ticket. When we run the cloud functions, we store every alert ticket ID in a Redis instance, then check ticket status, ticket creation time, and ticket labels for deduplications during runtime. It also has a local testing environment. So if a rule in testing status, the alert won't trigger any real notifications. Instead, the alert will be stored in a cloud logging file so that we can just check those without bothering the whole team. And most importantly, our notifications can be configured very easily and flexible. As you can see on the left side, we have a notification policy file come with the code, and you could specify like whatever notification policy you want. And for now, we support 3 different notification methods, which is handout messages, Jira tickets, and PagerDuty alerts. So if we want to specify like a new Jira ticket creation notification method, you can choose like what project name you want, what's the issue type. It can be a story, a task, or whatever you have, and you can specify the assignee and the reporters as well. Assignee and the reporters can be a static email address or can be a PagerDuty ID, so that when ticket created, it will be automatically assigned to whoever is on call. And you can also add customized labels to the Jira ticket as well. Then on the right side, every single rule has this field called policies. In this case, we use Chen test as an example. So in this case, all the alerts triggered by this rule will send a notification to Chen test notification policy, which is a handout message and a Jira tickets. After we add more and more rules to the system, and we start to getting more and more alerts as well. So we realize, oh, we are spending too much time on responding to those instances, and we probably should have some way to automatically resolve the instance as well as enrich the alerts. Our automation platform is powered by GCP Composer. And underneath, it's using Apache Airflow with lots of customized plugins that fit our environment. It is also very flexible. If we want to create an alert first, then using automations to enrich the alert is supported. If we want to do automations first, then decide if we need a ticket, we can do that as well. Here is an example of how we use automations to make our day-to-day life easier. Initially, our detection rules find an employee is trying to modify their MFA settings. Then our automations first find the IP of the employee is using, then review logs in our data store automatically, and leave the result as a command with instructions to next steps. Then the automation will ping the user say, hey, we found you are trying to modify your MFA setting using this IP at this time. can you confirm if that's expected? Then the user would receive an email, and the user replied in the ticket directly, say, yeah, confirming it was me, and I just learned I can use Face ID for my FMFA settings, so was enabling this. It's worth noting, like, during this whole process, no DNR teams, there is no DNR teams interaction in this whole process, and it all happens after business hours. I will hand over to Daniel to talk about our current status and our future plans.
So today, this is the detection response team at Cloudflare's primary SIEM that we've been using for over a year now. And we have, over time, added some more nice-to-have engineering features, like having monitoring for when one of our logging pipelines goes down. And this happens sometimes because APIs change, your credentials accidentally get rotated, or whatever that is. And so now we'll get paged, and we can quickly fix that. That way make sure we're not missing data. Other things we've noticed is that our SIEM's cost is almost half from GCP's cloud logging. What's cool about this is actually an entirely optional method that we've used for ingesting data, and we could remove this tomorrow and remove half of our costs, and this wouldn't impact our detection and response ability to write these rules or to do investigations. We've realized that our costs are about 50 to 70 cents per gigabyte, which, as far as we know, is the most affordable option, factoring in that we keep the data searchable for a full year. And from what we can tell, this is 20 times cheaper than traditional SIEMs. And yeah, like, they might have more features than us, and they might have easier to use experiences, but we don't think that's worth the 20x cost. Other cool things that we think about that we have are that this is entirely managed by Terraform. This allows for us to have multiple development environments. Like right now, I have 2 running, and those are for testing new logging pipelines, new automation frameworks, and API integrations, as well as we always have a staging environment and a production environment, and these all run pretty affordably, which is why we don't mind running so many of them. And what's cool about having this in Terraform is all of our access control and all the changes are very explicit, and we can do rollbacks really quickly if we need to. Next, after this, we're just getting started with this project, even though it's been in development for 2 years, and we need to do log normalization, enrichment, and we need to integrate a lot of the threat intelligence that Cloudflare has to offer in-house, and external third-party sources that the InfoSec community has as well. And we currently have some machine learning work in progress where it generates anomaly-based alerts off of any data set, but we need to make this easier to use and, more importantly, easier to understand for people who are on call and get these alerts, since it's not always clear why an alert goes off. And of course, the constant problem with detection response teams is you have to constantly evaluate new log sources to see how can we make these useful for emerging threats. If these sound like fun problems to you, we're hiring on our detection response platform team at Cloudflare, and we're happy to take any questions people have.
Hello, welcome to the Q&A for our Serverless SIEM talk. I'm here with Chen Cao and Daniel Stinson-Diess, who were our presenters. Thanks, folks, for joining us. First off, loved, I was watching your presentation. First of all, it's great to see you working with sort of these modern DevOps methods to produce this tooling. We've seen attackers more and more adopting these kinds of high leverage techniques to develop and deploy ransomware and the like. So, detection and response need to keep up if we're going to have any hope of iterating fast enough to contain the threats. So, I guess to that end, let's ask the hardest question first, right? A lot of the success of these sorts of cloud native platforms and other areas of the cloud outside of pure InfoSec, where they came from, observability, orchestration, containerization, deployment stuff, from the systems engineering as opposed to security signals and events. The success of that's really been related to open source and the formation of kind of a nonprofit community bodies to democratize and commoditize the kind of work you're doing here. Do you have any plan or any hope that you might eventually be able to move these out into a place where people can not just adopt your methodology, but actually, take bits of code that whatever is not tied closely to Cloudflare, stuff you're not worried about leaking, anything at all?
Yeah, that's a really good question. So we definitely have that on our roadmap. But currently, our team is still fairly small, and so like everyone like got their like other job to do as well. We do detections, doing instance response, like a lot of things like this. But we are also hiring. So we're like hiring some dedicated software security engineers for this project, and we're also hiring like a director for this specific project. So like if anyone is interested, can definitely come join us, and we can build this together and make it open sourced. And we definitely plan for.
That's some great pivot right there from open source to hey, let's recruit some people. That's chef's kiss, by the way. Thank you.
That's like this is actually the only question we have prepared, because like we know like people will ask about this, especially like we have spent like 2 years building this thing. Like it's definitely like a lot of time we spend on it, and like spend a lot of efforts. But yeah, like open sourcing this thing is not like just like say like click the button and it's open source. Like you have to your fingers.
Absolutely. I mean, and to be clear, I mean like things like Prometheus, Kubernetes, these sorts of like those took decades to go from like internal tools to public cloud native foundation stuff, right? So please don't take what I'm saying as like, hey, TikTok, why isn't it here already? I'm just curious.
No, we definitely want to, and we've as we've been developing this, we've kept most of like the Cloudflare specific things as like separate modules, and so we definitely like we've built it with the intent of doing that, and we'll definitely be doing that kind of piece by piece if we can't do it at one time, because there are certain parts with like there's no reason we can't share like our VS Code plugin for Sigma rules, since I think other people are using Sigma rules in VS Code. So like that's something that's immediately useful outside of the rest of the SIEM. But we definitely want to do that, and like Chen said, we need more people than just Chen and I to work on this to be able to support it, because we don't want to just release it and not have anyone answer questions or help people if they have problems.
Yeah, absolutely, sure. It's one thing to be a 10x engineer; it's another to be 100x plus sales and engineering and marketing, all the other things. No, absolutely. So then, on top of that, let's say you talked a lot about what you did, which was all very great and exciting. But what would you say are the things to watch out for if you are a security organization looking to create a new cloud native platform like this for yourself? Like if they see your talk, they grab the slides, they go to their team, they go, let's do this, right? And they need to put all, because it's not open source yet, they got to put all that stuff together themselves. What are the pitfalls to watch out for?
I think one of the big things is just know whatever platform you're developing is on its quotas and pricing point of views. I think depending on how you're developing it, like different services like the Cloud Functions and PubSub, which we use in GCP for messaging and kind of our compute, have different pricing models to where it's really smart to kind of do it one way. And then as we're doing our data warehouse in BigQuery, there's one really silly button to not check on partitioning your data by day. And if you don't click that and you accidentally write like a select star from whatever query, you can rack up a really, really big bill on accident. Which is, if you can justify it's for some security incident, like cool, no one's going to ask questions, but like sometimes you're just testing something and you racked up a bill, and that's kind of painful.
Sure. Yeah, consult your local cloud economist and put in some safeguards around.
Yeah, most platforms now support like setting billing quotas and things.
Yeah. Okay. We actually related to that. We had one of the participants in the Discord channel asking, I believe, 50 cents per gig per day for 365 days. Like that. I don't know if that's disbelief but any comments on that? Is that sound familiar in terms of like the sort of?
I think it's 50 cents per gig per month for the year we're storing it. So is that right, Chen?
Yeah, kind of. So like we can only see our monthly bill. We can't see we can see the like yearly bill as well. But like for the storage, like not all the data are stored for the same time. So like for our like monthly bill, it's about like for the new data ingested in this month, and for all the old data have been stored for like the 360 days. Like that's like around 50 cents to 80 cents between that range. And it's also worth to mention like half of the cost spent on like cloud logging, which is like totally optional. We use that just want to like make the search more efficient. But like if we just want to build detections and like rules and do alerting and do the search using SQL queries, you can definitely like ignore those and just skip those, and it can save a lot of money as well. So, but we still use that because like people may not be too familiar with like SQL stuff, so like they may still need like a more virtualized tool to like search logs, and we use that for the hot storage.
So yeah, it's an accessibility for your user base sort of benefit.
Exactly, because there's a lot of people coming to our company that, as analysts, as we're hiring that too. It's that come from like a Splunk or an Elk Stack background, and jumping from that to saying like, here are the schema tables for all of our data. Write a SQL expression that can do your unnesting and your data. Like you can't just pipe it to count and do stats.
Try not to drop all from
Yeah, exactly. So luckily we don't, like with our Terraform IAM situation, we can't really like, we make sure that people can't drop anything. It's just, we keep everything in cloud logging as more of a, you can write really quick searches and just like regex search across everything. And the nice thing about cloud logging right now is you're not charged per query, and you're just charged for ingesting data at all. So like once it's ingested, you can search as much as you want, nice. And it's pretty quick, and there's no real downside to just getting familiar with the data there.
So yeah, I actually, and one of the things I really loved about this was, as we talked before, like how this enables these DevOps models you're using, these sorts of things, but the fact that you can use this infrastructure because it's cheap enough, you can do those kinds of things and do blue green, or do, hey, we're going to run a 1% experiment over here, or we're going to spin up some new stuff to see how we can maybe if it helps with catching something, or if it keeps us from blowing stuff away when we're trying out something new. That's hugely powerful. So very, very cool. What is there anything else like that, other aspects of the system that you didn't get to dig into as much that also help further that, like stuff you didn't really get to highlight in the talk because of the time constraints? Or
I think another thing worth to mention is like we have done like great job on the automation stuff. Mm-hmm. So like for example, like we use like Apache Airflow. To whom like may not be very familiar with, it's basically like Python based, and you can like build your own plugins.
Very familiar with Airflow. We used it. Yeah. Actually, we had our own in-house system that we replaced with Airflow a couple of companies ago. So yeah. Yeah,
nice. So basically, we use that so that like when we deploy like some automations, we can easily add that, and like we do a lot of things like that. We can automatically like suspend users' account, isolate endpoints, like do forensic collections. Like don't even like need a real human interaction during the whole time. I feel like that's really cool. But like it's like Apache Airflow, like it's their own like itself can be a like separate talk. So yes. So we didn't spend like too much emphasis talking about it. But like we do have like a lot of our customized plugins and operators. We do have like build a lot of tags using it to help us like respond to the instance quickly. So at Cloudflare, we do believe like, so anything not urgent should be done like automatically, and we like to engineer our way to solve the problems. So like we like it a lot.
So where would you say in your current system, like what are there any sources of complexity left that you really like to kind of pull out maybe and go at this, as in the next iteration? If like you were like, that was kind of a blind alley, or it left us in a sort of an awkward position where we're spending a lot of maintenance on this or something.
I think there's a lot of work is like classifying, like when we get a new chunk of data, like which log index should this go to? Because like in classifying all the different data and making sure like, since we're building this in Go where we have static types and everything, we don't want to drop data. If like a new telemetry source adds a new field, we don't want to like not pick up on new fields into like our data types. And we want to make sure that like, we're not currently doing any normalization because we don't want to lose the context with each event, but something that's what we want to do over time and next. And so I think it's kind of the looking at data and seeing how do we normalize, how do we structure it and like make it searchable is kind of the next phase where it needs a little bit of love. Since it's
fair enough.
Yeah.
Okay. Well then I guess I'm out of questions, I think, at this point, unless either of you had anything else that you wanted to add? Okay. In that case, very much appreciate your time. I think this is very exciting, and judging, from what I've seen, there will be at least, a few other companies that are, and organizations that are really eager to dig into this as you put this information out there. So, well done.
Cool. Thank you.
Thanks for asking the questions.
See you next year in Vegas, maybe.